believe it or not, is to control cost. The pay-as-you-go model works great when you are starting off because you don't know how your data is going to grow. You don't know what kind of business requirements your BD team is going to come to you and say, hey, run this analytics for me. You don't know. You're just doing a proof of concept. So it makes sense when you're just kicking off your entire data campaign, you start off by looking at a public service, but later, as you see a predictable growth, you see for the first quarter, you see for the second quarter, you know how your audience is growing. You know how much data per day you are accumulating. You know that these are the standard set of pick queries that you want to run at the end of the day. And at that point, you would say, why am I paying a public cloud provider so much? I don't want to have an OpEx model. I don't want a pay-as-you-go model. Why can't I move from OpEx to CapEx? Because I now have control over my own growth. Right? How many of you feel that CapEx is an important thing to have versus OpEx? OpEx is operating expenses, CapEx is capital expenditure. So it's a one-time investment. You go buy your hardware and you bring it, you put it into your data center. There is no recurring cost to it. There is no monthly bill. But in an OpEx model, you do get a monthly bill from your cloud service provider saying you have consumed X amount of services from whatever, and here is your bill. And you pay in dollars, mind you. They don't have rupee billing yet. So as the exchange rate changes, your cost also changes. How many of you feel that CapEx is something that you're interested in? Yeah, so that's what you would call, see, it's your own resources. You'll have either a co-location provider who you have tied up on a yearly basis, that you have a contract with him, you buy a rack or a floor space, you have that. Then it's only your human cost, right? The labor cost. Your team who manages infrastructure for you. Most of the time, because the co-location center is so far away, like in the US or somewhere, you don't actually have your own people there. You will have a system with your data center provider who says, I will give you 50 support tickets a month or something like that. So there is operating cost, but it's not for the infrastructure itself, it's more for the management of the infrastructure. The second most important thing is, what if I have my own data center? How many of you have your own data centers? In your office, you have one room that is dedicated for servers, and the question is, the management comes and asks, hey, we have invested in these number of servers 3 years back or 4 years back, why do you want to use a public cloud? It's tough explaining to the finance team why you can't use the infrastructure that you have purchased earlier. All right? Now, the person who usually has to answer that would be the business team who are saying, I want to do X and Y. It's not an engineering problem per se, because engineers simply just implement whatever it is that they want to do. But the management will be asking tough questions saying, we've just invested in buying these blades, these NetApps, these Cisco devices, load balancers, why aren't you using it? So then the question becomes, why can't we use it? And the answer becomes, well, there is a lot of complexity in doing it. Right? So we might as well just move to the public cloud, throw away or give up the hardware that we have to do something else and just move big data to the public cloud. Security and compliance. How many of you heard of Snowden? One person's heard of, okay, two people have heard of Snowden. Believe it or not, there are companies and full countries out there, like Brazil, who don't want to buy equipment that's being sold by American vendors. There is Germany. They're all very paranoid countries who do not like what's happening out there right now. You don't want a third party to have backdoors into your own infrastructure. Our own government doesn't want to get Huawei products because they feel that the Chinese have a backdoor in it. And big data is where all your real data is. You have your transactional data, your billing information and whatnot stored in RDBMS, that's great. But what users are doing on your system is essentially what people use to put in wiretaps. As somebody who has seen wiretaps, I can tell you that everybody puts in wiretaps. Of course, you have to get a legal clearance before you put in a wiretap, but imagine that somebody goes and serves a subpoena to Amazon Web Services saying, hey, company X and Y is running their infrastructure over there. Amazon will simply say, here you go. And that doesn't work for some countries. So most of the adoption of private clouds or public clouds local within that geography is now getting more relevant. When you have a data center, say that's within India, an American company cannot send a notice from, a sub judice notice from US served here at the local police station saying, I want to get information from this data center here in India. And that's also the reason why there are no big data centers in India. There's no Amazon Web Services in India. And I don't think they'll come anytime soon either. So who are the public cloud providers here in India? I can't think of any. Well, there are cloud providers for namesake, but how many of them give you Amazon Web Services-like services, I don't know. And that's a big challenge, right? So for you to have security and compliance, either you need to have data center providers sitting here in India. There aren't too many of them. The service levels varies depending on how much you pay them. And if that's the case, what's your SLA going to be if you go put your data there? If you put your data in the US, you can get compromised, and that's not a chance that many corporates want to take. So what do? You build your own private cloud and move your data into your own private cloud. Does that mean you're still 100% safe? I can't answer that, but hey, you're reasonably safe from prying eyes. Yes. Yeah. It's not publicly available, right? It's within your data center. It's as safe as you want it to be. Security is expensive, all right? Nobody implements end-to-end. Let me use some very simple example. Nobody implements end-to-end SSL. Nobody implements it because it's expensive. Just because you have a browser which is running HTTPS does not mean your end-to-end tunnel is encrypted. There usually is a terminator, a load balancer, where you run SSL. The rest of the stuff is clear text. Now, given that public services are like that, I can only imagine where you might want to put in a wiretap. The first point is going to be at your ISP itself. Simply doesn't matter. You can be paranoid about it, but this is it. For the cost that you are paying for a utility computing services, this is what you're going to get. To implement end-to-end, edge-to-edge security is really expensive. Sometimes it doesn't justify the cost of it. So most of them just have what's visible to the end user as a security, but the rest of the stuff is all in clear text. The last thing that I want to talk about is a chargeback model. A company has got many business units. All these business units have some kind of compute requirement or the other. But how much is it costing the company?
And the final shortlists are how many?
Right?
Because I need to announce all.
In a regular infrastructure that you have in your office, you might have purchased 5 servers for the entire organization. And one particular team might have occupied all the resources, the rest of the guys are complaining. And you go to finance and say, I need more servers. And finance guy says, well, show me how you're using your resources. There is no way to charge back to that particular entity who's using those services and say, X amount of rupees or dollars is being spent to run the infrastructure of the sales team. or the data team, or the front-end team, or whoever it is. And the moment you have a private cloud, you get metering and billing. Just like how Amazon Web Services gives it to you. You'll have that meter, which basically says you've consumed X amount of resources, which spans all the infrastructure that you have in your data center, and you get this consolidated bill with which you can say, I have invested X amount of money in this team, what's the value that I'm getting out of it?
That is not briefing.
And that's a data point that management likes to go take it to finance and say, this is why I need more resources. Or finance will throw it back at you saying, well, you're abusing the resources that I've given you. You're not using it at all. So it's completely transparent from that perspective, and management can make informed decisions as to how they want to do it. But most people today run on bare metal. Essentially means you have a server and you install the software on it. There is no layer of virtualization there that allows you to track what somebody is doing. How many of you are using at least virtualization for big data?
Because I'm the one that is announcing things.
So when you go to your IT team and say, hey, I need five terabytes of space, or five 4 gig machines or whatever, they'll actually provision on VMware or Zen or something like that.
You can imagine what my flight is.
That's 1%. So at least there, that's a big two. That's pretty good, because you can actually do sharing of resources, and that cut cost significantly. The next iteration of virtualization is to basically build the entire cloud area, provide APIs to the dev team itself so that they can provision. So what are the building blocks? OpenStack, CloudStack, and OpenNebula are 3 popular choices for building infrastructure services. You've already purchased your hardware, great. You already purchased your virtualization technology, great. Now let's start controlling your resources and make it available to your own internal dev team and the data team and so on. And the popular choice is OpenStack, CloudStack, and OpenNebula. So OpenStack is what powers Rackspace. They've made it open source. You can go get the code and you can run it. CloudStack is a product that was formerly sold by Citrix. It's now part of the Apache Foundation, and it's completely open source. SoftLayer, which IBM acquired as a public cloud provider, runs on CloudStack. In fact, some of the largest clouds actually run CloudStack. And there is OpenNebula, which is already having a huge presence in the enterprise segment. Now, it's up to you, depending on what it is that you're looking for, to choose the right cloud operating system. All of them work with VMware, Hyper-V, Zen Server, Linux KVM, Oracle Virtual Machine, whatever it is. Then they work with NetApps, they work with EMCs, NetScalers, Foundries, whatever you can think of. It's just a matter of taste as to which one you want to use. Now, once you build your infrastructure services using your cloud operating system, the next thing is, can I get Elastic MapReduce? How many of you are familiar with Elastic MapReduce from Amazon? It's a wonderful thing, isn't it? Rather than manage your own Hadoop system, you simply go to a dashboard and say, here is my S3 bucket, here are my pig queries, this is my jar file, whatever it is. Click, click, click. Next thing you know, 15 minutes later, you have your data. It goes into Hive, HBase, or any of these data warehousing backends, and you're done. So that's what people really want. People don't want to manage Hadoop by themselves. They don't want to manage Cassandra by themselves. They don't want to manage any of these software components by themselves. They want to have a layer whose job is to manage the data itself, because it cuts down on the effort that it takes to manage it. You don't need to have a team who has to be certified in X, Y, and Z software, because you have a layer, a platform as a service layer, that you simply have a same workflow like what you have in Amazon. And the most popular one is called Cloud Foundry. Again, completely open source. It's part of a case study that I'll talk in a short while. And the moment you have Cloud Foundry running on top of these cloud operating systems, your dev team or your end user can simply go and provision an actual Elastic MapReduce-like infrastructure. He doesn't need to know Hadoop. He just needs to understand what's the query and where's the data. And to make all this happen, you need to have storage. We are very, very used to S3. S3 is this awesomely popular block storage, object storage from Amazon that allows you to do get and put on objects. You simply take this huge terabyte logs, split it up into 100 MB or 1 GB files, just put it over there and say, hey, Hadoop, pick the data from S3, and once you're done with your processing, put the data back. The open source equivalence of that is React, and the second one is called Basho. Both are completely open source. If you have just a bunch of disks sitting in your data center, you have your NetApp, you have your EMCs, whatever, and you want to consolidate your SAS, your SATA, your SSD, and all of these things, just put one of these object storing technologies, and next thing you know, you have this storage as a service that you now power your big data backend with. So in a nutshell, these are the building blocks that is very popular. Now let's get on to the actual workloads. So Hadoop EMR we just spoke about. Hadoop's backend is HDFS and Cassandra. These are the typical big data solutions that you have today that's catching on in the traditional enterprise. In the whole internet.com space, this is it. You'll never see anybody use Teradata or Oracle Warehouse or anything like that. Nobody does it. If you go to any internet company today, this is what they'll be using. I mean, no offense to the other people who come and spoken about it, but if you want the big bang for the money that you're investing in, software licensing cost and pay-as-you-go model. You have 1 terabyte of data, I'll start charging you X amount of money, now you start growing, it becomes X plus whatever, and support costs and all that stuff is basically not going to work for a majority of internet companies, like Yahoo. It's all, in fact, Yahoo wrote Hadoop based on a paper from Google. The idea is not to discredit the commercial offerings, it's just a matter of economies of scale, like in the case study that I'm just going to talk about next. So, Sky, for example, I hope that's visible. Okay, I have no idea how to make it bigger when it's in presentation mode, so let's mirror. Sorry, not happening. So I'll try my best to explain what's on it. So essentially, Sky is the black one, is it? All right. So Sky is a broadcaster, and they have set-top boxes that is IP enabled. So the moment somebody watches DTH in Europe using Sky's set-top box, they get events, and they want to see what's happening, start streaming, do a whole bunch of things, right? Sky is also an ISP in Europe. They have their own data centers. So the question was, why do I need to use Amazon Web Services for big data when I have my own data center? Okay? So the management comes and says, no, we've invested in our own data center, we will run our services here. Now the second part of the problem. Great, let's start building our own infrastructure in our data center to do Cassandra, because that's what they use to record user activity. It's a multi-master NoSQL storage, columnar storage that has got massive scalability when it comes to writes. And it has data center replication. You have it in multiple data centers, and it's eventually consistent when you write across multiple data centers, right? Facebook is powered by Cassandra. There's a whole bunch of stuff at Yahoo that uses Cassandra. Sky uses Cassandra. So many people do it. Now, the challenge was, my infrastructure is limited. It's not infinite. I might have 100 servers. I might have 100 terabytes of data. But what if I get hit by so much of traffic that I run out of resources in my own data center? So they came up with a strategy wherein which they wanted to do something called as bursting. The idea is that when their system hits 100% capacity, okay, they don't want to wait for 100%, say 70% capacity, the extra traffic has to go to a public cloud. And when you want to do that, you need to run your own PaaS service. And that's where Cloud Foundry comes into the picture. So Cloud Foundry is this platform as a service layer whose job is to manage the software services that run on it. That's your platform. So Cloud Foundry knows what's happening in your data center and then takes actions like auto-scale, failover, provisioning additional resources or deprovisioning them as the traffic grows and drops. So now Sky has the best of both worlds. They're using their infrastructure to the maximum, and in case they have more traffic than what they can consume, they burst into Amazon Web Services. So their bills only hit when they run out of resources on their own existing data center. The rest of the time, there's nothing in Amazon Web Services. And that's all controlled using Cloud Foundry. On top of it, they have additional requirements. They want SSL offloading. Every single request that comes into their activity trackers over HTTPS. Now, public cloud providers don't have SSL as a service because it's expensive to do so. You can put SSL recently on elastic load balancers. Previously, it wasn't there. Or you can run SSL on your instances. But the moment you add SSL, your CPU consumption simply jumps. If previously your web server was able to handle 1,000 queries per second, the moment you turn on SSL, it's going to drop drastically. Now, that's a huge cost. So Sky has chosen to go with a provider called Cavium, and they make this brand of SSL accelerators called Nitrox, which is there in just about every router you can think of, which provides IPsec services, or any load balancer that you can, of hardware load balancer that you can think of that provides SSL acceleration. So they bought these 60, 70 of them, plugged it into their servers, and said, these are my SSL accelerators. Right. Now, you can't do that in Amazon Web Services. You can't ship to Amazon these 100 SSL accelerators and say, can you please go and install it on my VMs? That's not going to work. So that's another reason why they had to use this model, wherein which they handle bulk of the traffic and then scale on Amazon Web Services.